We're going to work in section 2.5 with trying to understand the graphs of the secant, the cosecant, the tangent, and the cotangent. So hopefully already you've figured out that this is the graph of the cosine, and this is the graph of the sine. Y equals the sine of x. Now I put these in here as a reference because when we start looking at the graphs of the secant and the cosecant, really you're going to be looking at the reciprocal of these functions. So let's see what that's going to be like, and I'll look at it a little bit on my graphing calculator. So let me put this in degree mode for just a minute. Then go back to my stat tables. I'm going to take this second column, see if I can't take the cosine of the first column. So the cosine of the first column, so that'd be L1. There we go. Now that's just the cosine. What's going to happen when we look at the reciprocal of that? Well, the reciprocal of that, let's do that here, 1 divided by what I have in column L2. Now watch what happens. At 0, we get the cosine of 0 is 1, and the reciprocal is 1. But when you start moving away from 0, when you're starting to move along the curve of the unit circle, then the cosine, the x-coordinate, diminishes. What happens to the reciprocal, though? The reciprocal is going to start getting bigger and bigger and bigger. Now, eventually, we're going to run into a problem. We're going to run into a problem when we try and take the reciprocal of what number? Where's the cosine going to get down to? Cosine is going to get down to 90 degrees. What's the cosine of 90 degrees? Anyone? You're supposed to make me look good, right? We're mic'd up here. So, thank you. Cosine of 90 degrees is 0. Can you take the reciprocal of 0? What's your calculator going to say if you take 1 divided by 0? Is it going to like you? No. No, it's going to get in your face and say, look, there's something wrong here. It's an error. You can't do that. So we're going to have some problems with the graph of the cosine. In fact, we're going to have problems everywhere that the cosine is 0. So here, 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 and here, here, and here. All these places where the cosine is 0, we're going to have problems. You can't divide by 0. It's not defined. Question? No? Okay. All right, well, let's see what the graph looks like then. And I'll do that here up on Desmos. So let me go over here. First, I'm going to put in those lines. Those vertical lines are going to be called asymptotes. The graph will never touch those lines, but it'll get close to those lines. Now, you might notice there's a little bit of a pattern of where these lines occur, and it reflects the same pattern as where the cosine is 0. Cosine is 0 at specific values of x, and those values have a pattern. Let me write that down for us. I got to switch over back to here. So cosine of 0, or cosine of x, equals 0 when x is 90 degrees, but in radians that's pi over 2, or 180 degrees opposite of that at 270, which is 3 pi over 2, or back up to 90 degrees, etc. So in general, pi over 2 plus n pi. So what is n? N is an integer. So if n is 1, you get 3 pi over 2. 3 pi over 2. If n is 2, then you get 5 pi over 2. And so on. And then you can get negative pi over 2 when n equals negative 1, or negative 3 pi over 2, negative 5 pi over 2, etc. So you get these asymptotes where the graph's just going to go up and up and up, or down and down and down. So What does the overall graph look like? Well, let's turn on that graph in the secant function. And there you go. You've got these cup shapes. They face up. Whoops, something doesn't look right here. I hate when this happens. Is that the right phone? Oh, you know what? I got the wrong graph. This is the sine function. All right. Let's open up the correct one then. So let's see. There we go. Graph of the secant. Whew. All right. So there's a graph of our secant. And there you see it. The secant graph is these cup shapes. They're in blue. Let me turn off the graph of the cosine so you can just focus on the graph of the secant. It's these cup shapes that face up and away from the x-axis. Now those shapes are kind of predictable. You can see that right here at x equals 0, you've got this nice symmetric shape right here. Faces away from the x-axis. So let's draw those on our handout. Just go back to here. And let's see, what color do I want to use? Let's see. I used purple this morning. In touch with my sensitive side today. So up here, like that. And then they're going to alternate. So the next one is going to go face down. And then up. Now here's a good question for you. What's the period of the secant graph here? How far before this graph repeats itself? Well, if I go a distance of pi, is the graph repeating itself? It's 2 pi. It gets its period from the graph of the cosine. So the cosine and the secant have the same period. There's something interesting about the graph of the secant, at least the unshifted versions. It never touches the x-axis. It stays away from the x-axis. Does not cross it. Okay. Having sketched in this is your graph of the secant. See if you can't do likewise. Figure out what the graph of the cosecant looks like. See if you can't sketch in the graph of the cosecant. You've got the graph of the sine there. What's the graph of the cosecant going to look like? You should be doing pretty much what we did with the previous one. The one difference between the graph of the cosecant and the secant is where these asymptotes appear. The asymptotes in either function are going to occur when the reciprocal of that function, either the sine or the cosine, is equal to 0. So let's understand where those points are equal to 0 in the graph of the sine function. When you're graphing the sine function, sine is which coordinate on your unit circle? The y coordinate. So the y coordinate is going to be 0 at x equals 0, or at pi, or at 2 pi, or at 3 pi, 4 pi, etc. So this will equal 0. Sine of x equals 0 when x is a multiple of pi. So it could be pi, 2 pi, 0, negative pi, negative 2 pi, negative 3 pi, etc. So when sine is a multiple of, when x is a multiple of pi, then the sine of x is going to be 0. And its reciprocal function, the cosecant, is going to have that vertical asymptote. Let's graph one of these things on your graphing calculator just to see it. Let's do the cosecant. So go to your y equals key, clear out any function that's there. There's no cosecant button, and don't get confused with sine -1. That's something entirely different. It is not the cosecant. So we have to type in 1 divided by the sine of x. We got to adjust a couple other things. I suggest we adjust our window. And you may or may not, depending on if you're in degrees or radians, you may need to adjust your mode. So let me adjust my window first. I'll go from 0 to, let's just do 2 pi. I only want to see one period. After that, I think I get the idea. I'll leave the scale, x scale at pi. That means I'll get tick marks every pi units. You know, -3 to 3 should probably be big enough. If it's not, we can change it. If your graph looks a little screwy, it's probably because, or it could be because you left it in the wrong mode. You go back and do degrees, or change degrees to radians, and then graph it. So, there you go. There's your cup shapes. They face away from the x-axis. The important thing in graphing these things is figuring out, well, where does my sine or cosine function equal 0? Because those are going to be your asymptotes. Once you have those, you're in good shape. All right, any comments up to now? We okay with what we got here? All right, well, let's keep going then. Let's start graphing some other functions. Like problem number 28. Problem 28 is y equals -4 times the secant of x. Well, let's understand a few things about that. Y equals -4 times the secant of x. Now, some of our intuition from our work with sine and cosine graphs thus far is going to help us out here. First of all, what's the negative going to do to the graph? Flip it. Yeah, it's going to flip it around the x-axis. And the 4 is going to kind of stretch things. In fact, maybe if I'm clever here, I can give you a nice little demonstration of what that 4 can do, or what a number out in front of this will do. So let me put a number in here, call it A, and then add a slider. Let's watch what happens when I change the graph, the coefficient in front of the graph to, all right, it's going to start out at 1, and let's move up to 4. And the graph kind of just gets taller, right? That's what's happening. You're stretching the graph. Now, if I happen to make that negative, then the graph flips. So the difference is they flip right there. But then the graph just gets stretched away from the x-axis. Now, what you can see, if I zoom in a little bit, is you can see that this distance between these things grows. So that gap is really just kind of your new amplitude. It's what you would have filling in things if I had a cosine there. If I did, say, -4 cosine of x, that's the graph that kind of fills in the gaps. So, again, the secant is just the reciprocal of this. What we can do is figure out where the asymptotes are going to be, graph the asymptotes, and then just try and sketch in some those little cup shapes in between the asymptotes. So going back to here, the two things I have to remember are cosine of x equals 0 when x is pi over 2 plus n times pi. You could also write that as pi plus 2n times pi over 2, or better yet, let's see, it'd be 1 plus 2n times pi over 2. What it works out is to odd multiples of pi over 2. And by that I mean pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and likewise negative values as well. Negative pi over 2, etc. Sine is easier. Sine of x equals 0 when x equals a multiple of pi. So pi, 2 pi, 3 pi, 4 pi, or 0, negative pi, negative 2 pi, and on and on and on. So sine is a little bit easier. Sine is just multiples of pi. You're going to need these ideas again and again. So make sure that you have these memorized. It's going to come up later when we work with trigonometric equations, and it also comes up in the graphs of the sine, or this cotangent and the tangent. So right now, since the secant is really 1 over the cosine, I could write that as negative 4 over the cosine of x. This is going to be 0 at these odd multiples of pi. So on the back of your handout, should have some room for some of these graphs. So let's start with problem number 28. What I have already graphed for you are your asymptotes. It's going to be pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, and so on. What we have to decide is two things. First of all, do I have a cup shape up or down in this interval? And secondly, how far down does that cup shape go? The easiest thing to do is to just test a point right in the interval. So right in the center of the interval is x equals 0. If I take the time to plot x equals 0, let's see if we can't figure out what we get for y. Well, it'd be negative 4 over the cosine of 0. Hopefully you're not plugging in 0 into your calculator to figure out what the negative 4 over cosine of 0 is. What's the cosine of 0? 1. So that's negative 4 over 1, or basically negative 4. So that's telling me all I need to know. Why? Can I have a cup shape up in this interval if I have a point down here? No. So my cup shape has to be face down, right? And if it faces down in this interval, where does it face in this interval? Up. So now, how far down should I draw that cup? Height of 4. So that height of 4 is going to be right here at pi. So I'll put a little point there, and then a cup shape up. I'm not going to take out a magnifying glass and make sure that this is spot on. All right. I want to see the cup shape down to 4, facing up. And it should get close to the asymptotes here. I'm not trying to take real good care as to how I draw this. What I want from you is the general shape. I'll be judging you on the asymptotes and, you know, which way the cup's facing in each of these intervals. So now on the test, do you think I'm going to be drawing the asymptotes for you? No. All right. All right. Somebody said yes. All right. All right. Leave the humor up to me. What's that? Flattery gets you lots of places, but I'm not sure it's going to get you the asymptotes on the graph. So, all right. So there's your graph. Now we can continue it from here, but I think we get the general idea. These cup shapes up and down, etc. The big thing you have to determine is where are the asymptotes. You can also double check yourself with these things on a graphing calculator. There's nothing wrong with that. I'm not taking away your graphing calculators for this part of an exam. Let's try problem number 30. Problem 30 gives us 1/2 the cosecant of 2x. So y equals 1/2 the cosecant of 2x. So again, we have to figure out, well, you know, where are the asymptotes? If you wanted to rewrite this, you could. That's 1 divided by 2 times the sine of 2x. And the asymptotes are going to occur where the denominator of that function is 0. So what I need to do is I need to solve where 2 times the sine of x equals 0. So problem 28, or problem 30, I should say. Y equals 1/2 cosecant of 2x, which is 1/2 sine of 2x. Where is this equal to 0? 2 sine of 2x equals 0. Well, the good news is I can divide out the 2 here, at least the first one, and get sine of 2x equals 0. You can't factor this one out. You can't divide by that one. But I do know in general where the sine of something equals 0. Sine of something equals 0 when that something is a multiple of pi. So what that's telling me is that 2x is a multiple of pi. That's where your sine function is going to be 0. And now we'll solve for x. How do I solve for x here? Yeah, divide by 2. So x is n times pi divided by 2. That's where you should have your asymptotes. That's where 2x equals n pi, or the sine of that is going to be 0. Because the y coordinate at multiples of pi is going to be 0. Now let me help you understand where that's 0 by making a little chart. We'll just do a few values here for ourselves, different values of n. N, -2, -1, 0, 1, and 2. X is n pi over 2. Let's start out with the easy one. If n is 0, I'll go to 0. If n is 1, I get pi over 2. What about if n is 2? Yeah, 2 times pi over 2. Well, the 2's cancel, so you just get pi. You get symmetric results on the other side. You get negative pi over 2 and negative pi. These are the places on the x-axis where you should draw your asymptotes. So at x equals these values, that's where you're going to draw your vertical lines on your graph. So once more in this calculation, I needed to know where the denominator was 0. I can divide out the 2. That's not going to affect anything. 0 divided by 2 is 0. So I need to know where the sine of this function, sine of this, is equal to 0. Well, sine of something equals 0. Sine of x equals 0 when that x equals n pi. So what I did is I took the argument of the sine function, that 2x, and I set it equal to n pi, and solved. So that gave me these points right here. I've got pi over 2, pi, 3 pi over 2, let's see what else, negative pi over 2, negative pi, and so on. So the last thing to do is to figure out, all right, well, where's my cup shape? Is it going to face up or is it going to face down within these intervals? The biggest thing I want to see from you is the correct vertical asymptotes. You can take out your graphing calculator to figure out what the rest of the graph looks like. Being able to find these vertical asymptotes is key. It's up to you what you want to do here to finish graphing this. You can test a point like we did a minute ago, or you can take out your graphing calculator. All right, since there's not a lot of motivation to test a point, let's take out our graphing calculators. Let's figure out how we're going to graph this, how we're going to put that in. So I want 1/2 cosecant of 2x. And I'll show you a couple different ways to do that. Kind of the one that everyone would be able to do is do 1 divided by parenthesis, and you need a parenthesis around this entire denominator, 2 sine of 2x. The first parenthesis closes off the sine, the second parenthesis closes off the denominator. And then I can just graph it from here. So I'll just use the same window that I had a moment ago. But what information do you think I got out of this graph here that I wanted and needed? Where's this first cup going to face? Up. So that's what I needed. It faces up. It gets down to what point here on the y-axis? 0.5. 0.5, that's our coefficient there. That's what tells you how far down it gets. And then from here, it's just a matter of drawing these nice little almost parabola shapes. And they're going to alternate, facing up and facing down. So the next one is going to face down, and so on. And we'll just draw 1, maybe 2 more. But once you have where these asymptotes are, you pretty much got the graph. So this would be pi right here. Can anyone tell me the period of this graph? How far do you have to go before this graph repeats itself? Pi, right? So right there, distance of pi. You've got that same shape starting to repeat itself. So yeah, the period is pi. Okay, I'm going to need some participation a little bit more on the next one. Is there anything on 30 that you're a little unsure of still? Need a little bit more help with? Some guidance? Just want more clarification someplace? Okay. Let's try problem number 32 then. Y equals -3 secant of pi over 2 times x. Wow. Y equals -3 secant of pi over 2 times x. So this one's going to be a little bit messy, at least initially. I think in the end it works out pretty nice. Y equals -3 secant of pi over 2 times x. That's the same as -3 over the cosine of pi over 2 times x. So again, I need to figure out, well, where are the asymptotes? The asymptotes are going to occur where the denominator equals 0. So that means cosine of pi over 2 times x equals 0. These are our asymptotes. In general, where does the cosine equal 0? $90, $270, $450, etc. So we solved that a little bit ago, and we came up with let's see, which form do I want to use? We'll do 1 plus 2n times pi over 2. So I want to solve here for x. I want to get x all by itself. And a clever way to get x all by itself is to multiply both sides by the reciprocal here. The reciprocal of pi over 2. Well, that's going to be 2 over pi. So initially, maybe it's a little bit uncomfortable, but I think in the end, it's going to work out pretty nice. On the left-hand side, we get a lot of nice cancellation. On the right-hand side, we also get a lot of nice cancellation. Units of pi are going to cancel. The 2 is going to cancel. So on the right-hand side, what are we left with? 1 plus 2n. Now keep in mind that n is an integer. N is just numbers like 0, 1, 2, 3, etc. So if I do a little table like I did just a minute ago and plug in different values of n, -2, -1, 0, 1, and 2, let's see what kind of values I get. When n is 0, I get 1. What about when n is 1? 3. N is 2. 5. -1. -3. Basically just odd numbers, right? Okay. Just odd numbers. That works out pretty nice. Before I move on from this and start looking at the graph, are you okay with what we did? You're going to have to do this yourself about a week from today. So if there's something that you're uncomfortable with, get some help.
For secant, are you always setting bx equal to that formula, like 1 plus?
Yes. Yeah. So for secant, you're always going to use this one. 1 plus 2n times pi over 2. And for cosecant, you're always going to be using n pi. So you're going to set this term here. It's called the argument. You're going to set the argument equal to either n pi or 1 plus 2n pi over 2. It's one of those two. Always. All right, so let's graph this thing then. I've got our asymptotes here. What I want you to do is decide, what's the rest of the graph look like? Does it face up? Does it face down in each interval? Figure it out. All right, so what I'll do is what I typically do when I need to pause, because there's no pause button installed on the software. We'll do a manual pause. So when you're watching this at home, you can fast forward until I get rid of the pause button here. All right, go ahead. See if you can't finish graphing this. See what you come up with. Okay, so an easy way to test this is to pick a point in one of the intervals, in the middle of an interval. So 0 is a good interval to test right away. Let's see what happens at 0 into this function. So if x equals 0, what's y equal? Well, we get -3 times the secant of pi over 2 times 0, which is -3 secant of 0. Secant of 0, this is equal to -3 times, or -3 divided by the cosine of 0. What's the cosine of 0? 1. So we get 0 and -3. Of course, you could also graph that. Either way, you should see that you get a cup face that faces down in this middle interval. So like that. And then they have to alternate from there. So there's your graph of the cosecant. Pardon me, secant. Okay, how are we looking on the graphs of the secant there? All right. Let me take a break here. I'll have to split up the video into 2 segments, but I'll see you in a few minutes.